Determine whether the following systems represented by impulse response are stable and causal. Here 4 impulse responses are given. Few are discrete and few are continuous. We are supposed to check whether the systems are stable and causal. Let me take the first one, that is h of n is equal to u of n minus 1 minus u of n minus 5. So here first let me try to draw the h of n signal. It is u of n minus 1, u of n minus 5. We know that u of n is a step signal which is equal to 1 for n greater than or equal to 0. So u of n minus 1 looks like this. It begins at n equal to 1. So at n equal to 1 it begins. Its value is 1, 1, 1, 1, 1 and so on. So its amplitude is 1 always. This is u of n minus 1 signal. Now let me draw u of n minus 1, n minus 5. So n minus 5 is again unit step signal which begins at n equal to 5. So let this be u of n minus 5 which begins at n equal to 5. This is 5, this is 6, 7, 8 and so on. So here it will be 1. So this will be continued till infinity. So if you perform this minus this, only the sample from 0 to 4 exists. Rest these two will get cancelled because at n equal to 5 its magnitude is 1. At n equal to 5 its magnitude is 1. 1 minus 1 is 0. So only h of n consists of let this be h of n which is consists of only 5 samples 0, 1, 2, 3 and 4. It is 1, 1, 1, 1, 1. So this is h of n signal. Now we'll check whether the impulse response is stable or causal. Here we can see that h of n. So let me continue here. Here we can see that h of n value is equal to 0 for n less than 0. Therefore, system is causal. Now we'll verify whether it is stable or not. We know that the stability can be calculated as summation k equal to minus infinity to infinity h of k. We'll try to find h of k. So here we can see that k varies from 0 to 4, that is k is equal to 0 to 4 h of k. So here its value is 1 plus 1 plus 1 plus 1 plus 1. For k equal to 0 all the values are 1. So the value will be equal to 5 which is less than infinity. Therefore we can see that system is stable. If it is less than infinity we can say that system is stable. Now consider the second example, that is h of n is equal to 0.5 power n. Let me draw the signal so that we can understand better. Let this be h of n. Here n magnitude indicates that, mod n indicates that n can take values positive as well as negative. For n equal to 0, say this is 3, 4, 5 and so on, minus 1, minus 2, minus 3 and so on. So at n equal to 0 the value is 1, h of n is 1. Now at n equal to plus 1 its value is 0.5. At n equal to 2 it is 0.25. It is 0.125 and so on. At n equal to minus 1 its value is 2. At n equal to minus 2 its value is 4. and at n equal to minus 3 its value is 8 and so on. So here we can see that h of n value is not equal to 0 for n less than 0. Therefore, system is non-causal. Now we'll verify whether the system is stable or not. The stability is verified using the formula summation k is equal to minus infinity to infinity h of k. Its value should be less than infinity. If it is less than infinity, system is said to be stable. So here we can represent it as, here it varies from minus infinity to minus 1, that is k is equal to minus infinity to minus 1. The value will be 0.5 minus n, that is minus k in this case, plus summation k is equal to 0 to infinity 0.5. So here the value of n will be positive, that is plus k, or I can represent it as summation k is equal to plus infinity to 1 0.5 power plus k. So which is same as this one, plus summation k is equal to 0 to infinity 0.5 power k. So let me simplify this further, or I can represent it as summation k is equal to 1 to infinity 0.5 power k plus summation k is equal to 0 to infinity 0.5 power k. Or I can further simplify this as, so it is of form alpha raised to k, which is nothing but alpha divided by 1 minus alpha, because k is equal to 1. That is summation k is equal to minus, so therefore summation k is equal to minus infinity to infinity h of k is equal to 0.5 divided by 1 minus 0.5 plus 1 upon its value is 1 minus 0.5, or I can write it as 0.5 by 0.5. Here it will be 1 divided by 0.5, that is 1 plus 2, which is equal to 3. 3 is less than infinity, therefore it is stable. Now let me consider the third example, that is h of t is equal to e power minus t u of t. So let me draw the signal here. Say this is h of t, this is t axis. We know at t equal to 0 the value will be 1. Now at t equal to minus 1 the value will be e power minus of minus 1, that will be e power 1, which is equal to 2.7. It is greater than 1, so the nature of the signal looks like this. So this is e power minus t u of minus t signal, as it exists only from minus infinity to 0. So here we can see that h of t is not equal to 0 for t less than 0. Therefore system is non-causal. Now let's calculate or find the stability, that is integration minus infinity to infinity h of tau t tau. If it is less than infinity, we can say that system is stable. So here it varies from minus infinity to 0. H of tau is e power minus tau d tau. So integrating this, we'll get e power minus tau by minus 1, that is minus infinity to 0. So simplifying this, for tau equal to 0, it will be 0 by minus 1 plus we have e power minus of minus infinity is infinity, which is equal to minus 1 plus e power infinity, which is equal to infinity. Therefore system is not stable. That is h of t is equal to u of t minus 1. Let me draw the signal. So this is u of t minus 1, that is shifted step signal which begins at t equal to 1. So this is u of t minus 1. So here we can see that h of t is equal to 0 for t less than 0. Therefore, it is causal. Now let's see the stability, that is integration 1 to infinity h of tau d tau, which is equal to, value is 1 here, into d tau 1 to infinity. Integration of this is tau, the limit is 1 to infinity. So here it is infinity plus 1 is equal to infinity. Therefore, system is not stable.